Bismillahirrahmanirrahim. Students, welcome back. Assalamu alaikum. This is a paper, October 2022. Okay, and 43 variant we have. So we're going to solve complete mechanics paper P4. Question number 1. A particle P is projected vertically upward with a speed of u. And from a point on the ground, it means we are throwing a particle from the ground. So, all right. What happens then? And what is starting speed? We don't know. So you going upward gravity -10, you know, coming down +10, going up -10. P reaches the greatest height after 3 seconds. It means it reaches the maximum height at 3 seconds. It takes times 3. 100% confirm last velocity is for sure becomes 0. So what is the formula? You know, is V is equal to U plus GT or AT. And what is what is the final velocity? 0. Starting velocity, we don't know. Gravity going up -10T is unknown. And sorry, he said 3 seconds. Sorry, time is given. Time is given 3. So 0 is equals to U -30. 30 goes there, 30 meter per second. So alhamdulillah Rabbil Alameen. Part number next, greatest height. What is the total height? So this time, because distance is concerned, we have two formulas. S is equal to U T plus half GT square. As a teacher, I suggest you write formulas, although are open in a formula sheets. What happens that your eyesight can catch the formula easily depending upon data. This is data writing is a very, very important, and diagram making. Two things are key role. I have a key role. So I now think if I use the upper one, okay, we have everything. We can use upper one even, no issue at all. But I'm going to use the lower one. 2 acceleration, -10, S is a target. Last velocity is 0, U is 30. And S is equal to this a -900 and divided by -20. 0, 0 cancel, and S become 45 meters. Question number next. A box of the mass 5 kilogram, okay, mass 5 kilogram, is pulled a constant speed. Constant speed is of 18. It means speed is 18, 1.8, sorry, and acceleration is confirmed 0. For 15 seconds. So it means for 15 seconds. Rough inclined plane. And angle with the horizontal is 20. Okay, it means I will make this kind of diagram. It's just the teacher, don't make small diagrams, okay? Make little bigger. And he said that, and this is height. He's saying the box moves along the slope and frictional force given 40. So frictional force given by him 40. Data writing is very, very important, and diagram is also. This will help you to solve a question. And formula writing, which I'm going to do now. Force pulling the box in a parallel to the slope. It means, or I show you this even, no problem. So this is being pulled here, okay? And further, what is the change in gravitational potential energy? But this is the B for bottom and T for top. Naturally, here height is 0. So potential energy is confirmed 0. And we need a height to find it. And problem is that do we have this distance? No, we can find it. How? Because speed is constant. So we can use, what is the distance formula? Basically use in lower grades even. Speed multiplied by time is only applicable if speed is constant. So 1.8 into 15. And if I type in calculator, it is giving me 27. So 27, this distance is 27 meters. So opposite by hypotenuse is, you know it very well, is sine theta. So H by BT, which is 27, equal to sine 20. This multiplies there. So 27 times 2 sine 20, and I get the value 9.2345 meters. And student, now I can, now what is the target to find it? So potential energy change. So naturally, change in potential energy is very clear. mgh on top minus mgh at bottom. Bottom is 0. Now mass, you know it very well, 5 kilograms. Gravity 10, height is 9.2345. So if you multiply, so we get answer 461.727. If we don't want 462 joules. And I hope so you got a point clear. Next part, work done by the pulling force. So now we concentrate here. This is applied force, and you know it variable, students, friction force acting downward and the weight component. And what is this? Mass of 5. Mass of 5, so weight acting downward is 50 newtons. This is a 50 sine 20. Because system is going upward, motion is going upward. So what is the basic formula used for this kind of questions? Net force is equals to MA. And this applied force minus friction minus weight. Applied force minus friction minus weight component equals to MA. Mass is a 5. Acceleration with 0 because it's moving constant speed. So I will bring and on the right hand side both friction plus 50 sine 20. Okay, I will get, what is the friction? 40. So when I applied formula 40 plus 50 times 2 sine 20, I get 57.101 newtons. And what is the work done by applied force? Formula applied force into distance. Distance, you know, 27 meters. So 57.101 into 27. And we are getting 1541.727. Or rounding, I won't want 154 and 0 joules. I hope so this point is clear. Let's go for question number 3. Okay. What question number 3, students? He mentions here a ring of the mass 4 kilogram is threaded on a smooth circular rigid wire. So rigid wire, this is a rigid wire, okay? Rigid wire with center C. So this is a rigid, I can say solid particle, solid thing, okay? Like a ring, we can say, okay? All right, in this situation, when particle is, this situation comes to the most important thing. Let me read a question first. Is a wire is fixed in a vertical plane and ring is kept at rest. This ring is at rest. Okay. And connected with the A. All right, so this is a connected there. And current situation, this is at rest. No motion is there. All right. And he said that the string makes an angle 25 degree and find tension in string and magnitude of normal reaction. Tension, you know, when a particle is hanging downwards, weight, let's say 50 newtons, where is tension? Tension is upwards, okay? Like you holding this object, so you feel tension in your arm, okay? And let's discuss another situation. If we have this kind of situation, this is a weight hanging downwards, tension will be this way. I think you're understanding. So same story, if weight is acting downward, 40 kilogram, 40 Newton, sorry. So tension, it will be 100% will be upwards. This is the logic number one, which I try to convince you. And I think you're understanding what I'm saying. This part is done. Now, students, the most important part is this. Many students confuse where is a normal reaction. I tell you one thing. Because rigid body, so whenever, for example, this is a radius and this is a tangent, and normal reaction in this kind of question will be outward normal, like this. This is called normal. Okay. And if let's say it is a here, so this is a 90-degree and this is R. Okay. And I believe you got a point clear. Okay. And if this is acting this way, so where is R? Exactly outward normal. This is a 90-degree. This is an R. Actually, this is called tangent, tangent, tangent. So same story, I will make a tangent. And tangent is drawn. Hold on, let me make a proper tangent. Okay, if I join this with this straight, so this is normal reaction. I think you got my point. Now, this question we can do in two ways: resolving forces, right forces equal to left forces, upward equal downward. Method number two, Lamy's rule. Lamy's rule is what? I just quickly explained to you. Then I come back. Lamy's rule is what? Quick revision. When three forces acting on a two situations. Condition number one, equilibrium. Number two, this applicable only in three forces acting on a point. Three forces acting concurrent for concurrent means acting on a one point. So this force is F1, this is alpha. This is F2, this opposite angle beta. This is F3, this become gamma. And actually you heard sine rule. Sine rule is a Lamy's rule, same thing. What is sine rule in triangle we apply, you know very well. This up and sine of angle down. This up and a sine of angle down. So same story here. This up and sine of angle in denominator. This force up and sine of beta opposite angle in denominator. This up, I think you're understanding, student. This is Lamy's rule. Quick revision I have given. So now I'm going to apply. This is another way to apply. Because three forces, where are three forces? I can show you force number one, force number two, and force number three is this. So three forces acting on a particle. Okay, let me show you the red color arrow. So it means three forces. If I find the angles, most important thing, angles. If I get the angles between three forces, question will finish. So let's try to do it. So let me show you, this is a tension. This is 40 newtons acting downwards. And this is R. Now students, one by one will try to find the angles. If I find the angles, question will finish. I can apply Lamy's rule easily. First of all, can you see, student, there's a circle property whenever we have a triangle inside circle. There's a radius, and radius equals to each other. Corresponding opposite angles are equals to each other. This is a 25, so this is a 25. So in this sense, this is 25. Second property, which is a very important circles property. that whenever a radius in a tangent, what is angle between radius and tangent is always 90 degree. So this is a tangent, this is a radius. So from here till here, 90. But problem, we don't have this angle. If I get this angle, I will get this, then I will get this, I will get this, I will get every angle. So this angle now we look upon how we can find it. I will show you two parallel lines, which will help us to understand. See one line here. You see, this is an important part. And I show you once again. This is 25. How come? Look, I'll show you in a black color or even blue color. This north, this north. This line joining. If this is a 25, this 25. If this 25, how much is angle? 180 minus 25, 25. So Alhamdulillah Rabbil Alameen, I believe you got a point. So I'm writing here, this angle is 25. And what is other angle? This is 180 minus 25. 155. So from here till here, 155. It means from 155, I must subtract 25 and 19. So students, I hope so you're understanding 155 minus 25 minus 90, I got 40. So this angle, I got a 40 in the middle. So basically this angle is 155. So I think this is a very clear, this angle 155. And this angle, you just got it 40. And again, as radius and even extend outside, you see this diagram, if this is 90 degree, then how much this 90 degree? So how much this 90? Out of 90, 40 gone, how much this 50? So if this 50 between R and 40, so this is 50. And this angle, how to find from 360 degree, subtract both 360 minus 50 and 155. I got 155 once again. I repeat 360, subtract 155, subtract 50. I got 155. I think students, I'm eligible to use now Lami's rule, this up, sine of 50 down. One unknown and second must be known. 40 over sine 155. Sine of. So this will multiply there and I will get my answer. So this is Lami's rule. Otherwise, I can go for second method even, no problem at all. I have shown the resolution of angles. You can go for second method even. And I got this answer 72.50. Okay, student, I can go for second part, same Lami's rule, but this time I will not use this angle. I will use R and this. And equals to one unknown and one must be known. Now we have a T, we can find even this also, no problem at all. Sorry, it is, it is. So it means, you see, student, they are cancelled, you see, they are cancelled. And R, I got a 40. So Alhamdulillah Rabbil Alameen, I believe you got a point very clear. Second method, I said you, if you want to know in quick time, this is this. This is T cos 25. This is a T sine 25. Done. And this R has this R cos 50, this R sine 50. Done. 40 is downward, it has no component breaking. And then you can write, say right equal to left and upward equal to downwards. You can do this method even. Let's go for next question. Next question number 4. A particle is traveling, P travels in a positive direction. So here, along a straight line, the constant acceleration. Whenever constant acceleration come, we can use equation of motions easily. Equation of motions, all whenever constant acceleration comes. P travels in distance of 52 meters. So distance is what? 52 meters. And P travel 20 in seconds, second of the motion. And distance 64 during 4th second of the motion. If I show you the idea, maybe inshallah, this diagram will help you. Starting here, 0, and time is 1, time is 2, time is 3, time is 4, and time is 5. So students, what is the basically plan? He said distance traveled in second. Second, start when first second is finished, and this is a starting. This is called second. And I distance is a 52 meters. And distance of 64 in a fourth when it starts, when third finish, this is called 64-meter distance. And these are timeline I showed. This is a time actually, time in seconds. So these are time 1, time 2 second, 3 second onwards. He said, find out the initial speed when of acceleration of the P. We need to find speed and acceleration. I hope so. The diagram is clear, and let's see how we can start this now. So we will apply this technique. How? Look at here now. So can I say, student, distance between this time and between this time is 52? Yes, you can say. Or I can say distance 52 distance is actually S2 minus S1. 2 stand for in 2 seconds, S1 stand for in 1 second. So let's apply the formula. Now, which formula we use? That's interesting. Let's try. If I use S is equals to, look, I show on the top better space, I need space. S is equal to UT plus half AT square. Or second, 2AS is equal to V squared minus U squared. As a teacher, it's just you write both formulas in front of you, okay? And check which is suitable to use, depend upon the parameters given. Starting speed is here. Initial speed is V is equal to U here. Okay. And throughout, I said acceleration throughout remains same. A is A. It's not changing. So if I use this, I can use, but harder for us. I need starting ending velocity. Ending velocity we don't know. So I think this better don't use this one. We can use it, but it's a little bit complicated. So this is better to use because no final speed concern. And time we know, A we know. So let's apply. So I'm writing UT. See, I'm writing here UT plus half AT square for one thing, and minus UT plus half AT square second time. So, but I will, U remains U, and time is, first I use T2. So every T replaced by 2. Every T replaced by 2. So 52 is equals to, when I put 2, I got a 2U. When I place 2 squared, 4 is cancel out. I got it again 2A. Here, when I replace 1 into U, I got a U. When I replace this 1 again in this, I got a half, but plus into minus half A. So I hope, student, you understood how I got it. 52. Finally, I got it 52 is equal to U minus U. I got a U, and 2 2 is a 4. Out of 4, 1 gone, 3 plus 3 by 2A. So I got this equation, or you can write 1.5 even. If you want to avoid this fraction part, 1.5. Equation 1 done. Same approach, student, I can say, what is this? This is called S4. What is this? S3. So I can say that 64 is equals to S4 minus S3. This time, I'm not showing the formula. I'm writing directly plug-in equations, values. Now, apply here, U is same, T is 4. So 4T, sorry, 4U. Okay. When I plug in 4 here, 4 square 16, 16 divided by 8a, I got 8a. Minus. When I plug in 3 now, this is becoming 3u. When I plug in 3 here, 3 square 9, I got a 9 by 2 become 4.5a. Expand the bracket, I got a 4u minus 3u, I got a u only. Out of 8, subtract this, I get a 3.5a. Okay, I think clear equation number 2. And student, I will bring equation number 1, copy and paste here down. And student, I will solve sign change, you cancel. I got a, and this is becoming 8. Not 8, sorry. This is becoming 12. Okay, what about this is becoming 5? Not 5, sorry, 2. Yes, out of 3, 1 gone 2, and I got acceleration 6 meter per second square. So I hope so this part is clear. Now I will plug in this 6 in any one equation. I plug it here. So 52 is equal to u plus 1 point. This is a 3 by 2. We can write even time to 6. So 2 3s are 9. 3 are 9. 9 goes there. And u becomes 43 meter per second. I think, student, you understood how I handle the question. Let's go for next part. The distance traveled by the P during first 10 seconds of the motion. First 10 seconds. So it's so simple, student. S is equals to ut plus half 80 square. T is 10. And obviously, u, I just got it. U, I got 43. U, I got it 43 into 10 plus half. The acceleration, I got 6, 10 square. An answer is coming with us, 730 meter distance. Okay, so let's go for the next question. Question number 5. What are question number 5? Particles X and Y move a straight line through A and B. Okay. So two particles move in a straight line through points A and B. The particle P starts from rest from A. Okay, it means at A, velocity is equals to 0, starting of X particle, and moves towards B. Okay, all right. It means if I just make a small rough idea, so you may understand, this is A, this is a B. X is starting from here and going towards this. So, and he mentioned starting velocity is u0 here. And he said the same instant y start from rest from B. Okay, the other particle is starting from here and coming this side. Okay, okay, so through AB. All right. Okay, listen to me. After time t, because maybe, okay, we'll read further first. After time second, after particles start moving, and the acceleration of x is a y, this is x. In direction of AB is this. And the same way acceleration of AB, it means is this. All right. And then one thing is very clear, as passage of time, if I plug in this time bigger, so this will increase. As time will increase, this from, for example, first times 0, we have a -8. As this will increase, so this acceleration will increase as well. Okay. So given that velocity equal when they collide, that it means they are coming toward each other. We have a one possibility, even B can go this way also. So we have two possibilities of collision. Okay. So he said that find the velocities given that velocities of both particles are equal. Velocities of x and y are equal when they collide. It means velocity of both particles are equal to each other. Vx and Vy are equals to each other when they hit to each other. So this is objective. So calculate distance between AB. So we have to find out this distance. This distance. Okay, students, so let's see now how we can start. So first of all, student will try to use this connection. Both velocities are equals to each other. Then we can get the find the time in the middle where they meet, because collision is there. But problem is only one we have here. These are accelerations and I need velocities. So you know it very well, three levels are there. Let me show you displacement. If you differentiate, you get velocity. Again, differentiate, you get acceleration. So differentiate, differentiate. But if I want to come down from acceleration to velocity, I must integrate. Same velocity to distance or displacement, I will go for integration. So step number one, because these are accelerations, I will integrate. So let's go for both. Okay, if this is for X particle, this is for Y particle. So if I in acceleration given, so acceleration is 12t plus 12, and acceleration is 24t minus 8. Integrating both sides, and when I integrate the acceleration, I will get directly velocity. 12t plus 12 dt. So when I integrate, increase the power by 1 divided by same, and 12 become 12t and plus c1. Okay, but thing is that, you know, the particles both are starting from rest. Particle A start from rest, B start from rest. It means when time was 0, velocity was 0. I would put velocity 0, here 0, here 0. So C1 becomes 0. I plug in back in equation. Finally, I got V equal to 6t to power 2 plus 12t. So velocity of X particle, I got it. Same process, students. I will go for it. Integral sign 24t minus 8 dt. Integration of 24t becomes squared by 2, 8 become 8t plus c2. And as you know, time is 0, velocity is 0. I got 0, 0, and C2. So C2 becomes 0, so Vy becomes 12t squared negative 8t. This is my semi-answer of velocities. And he said they are equals to each other. So I'm writing here as Vx and Vy equals to each other. So I can write 6t to power 2 plus 12t equals to 12t and negative 8t. I bring this both on right hand side. So out of 12, 6 gone, I got a 60 squared. This will go and subtract, I got a negative 20t. So this is a one possibility common and two common. And I got a 10. 0 writing here or there, not a big issue. I got a time either this 0 or that 0. So I got 2 times t is 0, but I will not take the starting, and here 10 divided by 3. Second time is when they meet, when they will meet, they will collide. So what is the time? 10 by 3. And now we'll work on it. It means in the middle, 10 by 3, the time with the meet. But important point is going to come. And whenever you have a velocity expressions, okay, how to get distance, students? Because he's asking find the distance between AB. So how to find? And I show this diagram now, another one. It means this going this way and this going this way. In the middle, they meet. And this distance plus this distance, I will find and add them both. Okay, So, so let's see how we can do it. And both, it means 0 to 10 by 3 and 0 to 10 by 3, I will integrate both. Because and when a velocity given, how to find distance, I once again integrate. So let's go integration once again. And I'm going to do integration once again. So this integration, I will get naturally, I'm the level of velocity, I need distance. So I will get Sx. Integral sign 6t square plus 12t dt. But I will get 0 to 10 by 3. Same Sy. 0 to 10 by 3. And I am writing 12t to power 2 minus 8t and dt. Increase the power by 1 divided by same. Increase the power by 1 divided by same and limit 0 to 10 by 3. Okay, same way here. Increase the power by 1. And this is 8t squared by 2. Okay, students, let's find both Sx and Sy. Now, important point, wait a minute, let me check. If I do it this, my first answer is I'm getting here. Hold on, let me find out. This is coming with us. This is coming with us 2 times 2, 10 over 3 to power 3 and plus 6 times 2 and 10 over 3 to power 2. First answer is coming 3800 by 27. But Sy is what? Let's try to find it. And that is a 3 4s are 12 because this is a 4 4. Okay, 3 4s are. In a 4 in a bracket, I'm writing 10 divided by 3 and power is 3. Negative 4 times to what? 10 divided by 3 and power is 2. And giving me what? It's giving me 2800 by 27. But you're surprised to know one thing, very important. What is that? Which I'm going to show you. Normally, we add, okay, we have to add distance and distance. But you're surprised to know if observer's eye is here, and one particle is going away from observer's eye, going away, velocity positive, coming backward, velocity negative. Okay, student, is a very important point in this particular question. So many students never concentrate. Look at here, this is coming backwards. So velocity is 100% negative. Okay, and the distance is also must be negative. So it means, and if I can show in this diagrammatic explanation. So look at here, I show you. See, I have two equations. This is a first distance by x. This is, sorry, velocity. This is not distance. Velocity by x, velocity by y. And you see this is a due to, because this one particle is going, this observer's eye, for example, one is going away and second coming back. You see this below x-axis. And below x-axis means is going back. So this distance is below x-axis 100% negative. So that is logic behind it. We have to focus on this. It means this answer is coming negative. So I did not have negative, but actually now basically, if I want distance, total distance, I must add them. This is a basic rule, but I will not add now. I will subtract them. Why subtract them, sir? Because this negative sign for this is coming back to observer. And I hope so you got a point. Although this is coming positive, because if you or look at one thing, you can put here negative sign. This is negative sign for what reason? For below x-axis. This is the second method. Or that minus, if you don't put it there, so do you put must here? So that is why, and I think now if I find this answer, you will get the required answer, which I am getting in fraction form 1000 by 27. And in meters, it is giving us 37 meters, 37. So this was a technical point, and this is one of the most important point is this one, why I kept negative sign. Okay, I think this point is very clear because going away, velocity positive, coming back, velocity negative with respect to the observer. So I think point is clear. And now we go for the next part. B part is instead that AB is 36 meters. Okay, this distance is 36 meters. Verify X and Y collide after 3 seconds. Yes, students, we have two methods, but the best method is what? I have to confirm that at 3 seconds, when they collide, the distance between them is 36. Okay. I have two methods. Okay, student, this is a distance traveled by X and this is by Y. And if I simplify, this is what coming CX, SX, sorry, this is becoming T2 T to the power 3 and 6T squared. Okay, I just leave it here, 10 by 3. This will help us. 4T cube and minus 4. 2 4s are 2 2s. Okay, T square. So student, this is our expressions for both displacements. And what we do, minus sign. So why we can't say this displacement minus this displacement equals to the gap between them 36. And if I solve for the time, I must get 3. This is a one choice. Okay, I show you what I'm saying. I have two choices. Oh, wait a minute. This is 1. So copy and I paste here. I have these two things, students. This is SX, this is SY. Okay. Because I integrate, yes, I got SX. Now, one choice is what? As I said before, SX minus SY must be 36, as he said. So let's try to solve it. But this will create some issue reason because cubic power is not in our syllabus to solve. Okay. And second method is what, students? I have the integration, we have it. If I integrate 0 to not 10 by 3, if I integrate 0 to 3, 0 to 3, okay, students, I must get 36 answer. This is method number 2, okay? So let's try to do that way. So I am doing it now. What way? This limits, which have done integration 0 to 3, and this limit, I'll go for 0 to 3, and then I subtract them. So let's see what answers come from this and SX minus SY. So I just plug in the numbers and let's see what XX1. Oh, I'm sure it's inshallah come 36, but let me type in calculator. It means the first I plug in this one, 2 times to 3 to power 3 plus 6 times to 3 to power 2. Negative 4, 3 to power 3 and minus 4, 3 to power 2. And let me type in calculator. So 2 into 27 plus 6 into 9. I get a 108 minus. So 4 into 27 and minus 4 into 9. I got a 72. And when you subtract 72 from 108, I got a 36 meters. Verified. So we have two techniques as I showed you. Okay, we have, but first method is a little bit hard. That cubic question to solve is only in a higher grades, grade 12. Anyway, the point is very clear. And let's go for the question number 6 we have now. A car of mass 1750 kilogram is pulling a caravan, okay, caravan, and of mass 500. And car and caravan are connected by a light rigid tow bar, okay, and resistance to motion. Many students confused by this word, resistance of motion. Resistance to motion of is mean friction force. This is friction of caravan, okay, and this is friction to sorry, yeah, this second is a first is a car, second is a van. I pronounce van, okay. So they move at constant speed of 24, so acceleration is confirmed 0. Find the power of engine. So let's try to show. Uh, First part we can do without showing the tow bar and everything, because we consider them as a connected one particle. Although they are different particle, we will deal them together. We'll them because they're connected, and we suppose so we add them both. Although they are separate, okay, we add them at the mass 1750 plus 500. So applied force and backward friction force. What is the basic formula? Net force is equals to MA. Now you have one general question, why you have taken, sir, one combined particle. Okay, applied force minus friction force equals to MA. Applied force is what? He said power. And what is the power formula? You know, power formula is basically force into velocity. Okay, and if I bring it down, so force becomes power by velocity. So this value is coming here. So power by V minus friction equals to MA. Power is a target, velocity constantly given 24, and friction I'm going to add even. So I'm adding, so it's becoming 800. Wait, let me check. Yeah, if you add them, yes, it's coming. 6 plus 7, 8, 800. Okay. And this is 0 because it's, I said you, okay, this will go there and multiply with 24. So 800 times 224. So answer is coming with us 19200 watt. But we have to answer kilowatt, 3 jumps, decimal is here, 1, 2, and 3. So it turned to be 19.2 kilowatt. Okay, this part is done. And let's go for next part. Next part, student, he's asking what here? The engine power is now suddenly increased to 2 means power become 40 kilogram. Kilowatt, sorry. Kilowatt means 3 more zeros. Watt. Instantaneously acceleration of car and caravan are caravan, okay, find the tension and tow bar. Whenever he asks you tension and acceleration especially, then we have to deal them separately. So let's try to answer for that. Okay. This diagram is very important to make it. Okay, so this is force. It is very clear, and you know force is equal to power by V. Okay, and tension and tow bar will be 100% towards each other. Tension and tension. And this, what is the friction here on the car? And 1750, let me write the masses in the boxes. Second mass 500. And friction on the car, this is the car C. How much friction? 650. And here I write friction on the V for van. How much? 150. I think student, you understood the way how I drew that diagram. And now I'm going to make 2 equations and solve them simultaneously. So again, same story, net force equals to MA. This formula I will use twice. Whenever you confuse how to start, write this formula become easy. So net force, so applied force minus friction minus tension. How many forces acting on this one? So don't consider this, okay? All right, so I will say that force minus friction minus tension equals to ma. But okay, but acceleration will change now. That is why I said acceleration, find it. So mass of this is 1. Okay, I'll write later. Now plug in the numbers. Power by V. Power is 40,000. And divided by what speed? I think it is he said that suddenly change, but you see this power and this A and this A part. So this title, you see this part A. So two part I and two both are under it. So this speed is implements on this also. So speed I will take 24. Okay, wait, just wait, please. Yes, it is. Yeah, correct. Friction is what? 650. Tension, I don't know. Mass is 1750. And acceleration, I need to find. Okay, student, 40,000 divided by 24 minus 650. I subtract these two values. I'm getting here 1 6, sorry, 10, not 16. 1016.666 minus tension equal to 1750. Acceleration. Equation 1 done. Okay, equation 1, okay. Now let's talk about the same story for the second one, but this time I'll use these forces only. So net this forward, this backwards, tension minus friction equals to MA. Tension, okay, leave as it is. Friction is 150. Mass is 500. Acceleration I want to find. Equation number 2. Okay, equation number 2. I'll copy this equation, students, and copy, and I'll paste down here. When I paste here, students, what will happen? Naturally, you know it very well. This negative tension plus tension, they will cancel each other. And now from this number, subtract 150. This. In decimals, I'm getting 866.666. And equals to what here? This is a acceleration. So 0.522. So it means 2250 when divided, I get the acceleration 0.385 meter per second square. And he was asking about acceleration and tension both. So this acceleration, I can plug in any equation, but here's better. Tension minus 150 is equals to 500, 0.385. Actually, for after 5, we have 18 or 19 even. No problem. So I'm multiplying into 500 and plus 150. My answer is coming more accurate. And that is a 340. 300 and, wait a minute, students. Yeah, sorry, 342.59. After rounding 343, because I don't find 343 newtons. Okay, student, let's go for next part. What a question. Next part is saying car and caravan now traveling up straight hill, incline this angle. This is angle alpha. Actually, I will take alpha like this. If I bring sine inverse this side, so what will happen? It will turn to be sine alpha is 0.14. So this is very clear. And I'm going to make it diagram here. Big diagram, at least you make it. Okay, otherwise chance of mix up. All right, same story. And he said what? Traveling up. It is their system is moving upwards. I mean on the inclined plane. Car engine is working now at this one. So power is what? 31000 watt. Okay. Friction to motion of car and are unchanged, remain same. And students, what we have to find out the velocity. He did not ask us to find out the tension or the tension or we can say acceleration. Okay, he asking us the velocity. So students, we can combine them. We can combine them. I said you whenever he asks you tension, acceleration, we are bound to make them separate. Otherwise, we can combine them. Same story here. I can combine. So when I combine, what happens, student? Let's see. Actually, they are together, student. You can see that this is a together. Okay. So, but we will deal as a one component. Okay, this is applied force. This is frictional force. This is mg sine theta. And okay, and force is what? Power by V. So basic formulas remain same. Net force is equals to ma. So applied force minus friction force minus mg sine theta is equals to ma. Applied force power by V. Okay, power is what, student? I'm just writing directly. 31000. V is unknown. Friction force, I will add them both. And after adding, friction becomes 800. Okay, and mass becomes yes, what is the mass? 2250. Yeah, 2250. Mass become 2250. Let me recheck. 5 plus 5 to 2250. Correct. So 2250. So friction is 800. Mass is 2250 into 10 into sine alpha. I will take directly, not this one. So 0.14. And mass 2250. Acceleration is wait a minute. He said what here? Let me read. Part B is saying is unchanged. And I think so. Acceleration. This is a given. Okay. Let me read again the question. Is said friction. Okay, traveling up. Constant speed. Yes. Because I thought this is a constant speed. And acceleration is confirmed 0. Okay, then no need to write this even. Okay. Now student 31000, stay here, rest all go right side. And I just calculate even 800 plus 2250 into 10 into 0.14. And I'm getting here 3950. And V becomes 31000 by 3950. And finally, 7.85, 84 actually, 84, wait a minute, 7.848, 84810. Rounding 3 SF 85. I believe the point is very clear. The question is, okay, finish. And let's go for next question, number 7. Question number 7, what the question demand here? You can read a question. Particle masses is 1.5. Particle mass is a 3. Okay, plane, inclined plane is alpha. Tan alpha is given by 3/4. And I said you 2 ways to get the other things. Okay, let me decide first. 3 over 4 means opposite by 3 is opposite, 4 is adjacent. So 3/4. This is by Pythagoras theorem we can find. And I got 5. Cos alpha is naturally adjacent by hypotenuse. And cos alpha, sorry, sin alpha, opposite by hypotenuse. Okay, read further. The section of plane AB smooth. Okay, AB smooth. So this is friction is equal to 0. And section B to C is rough. This section friction is not equal to 0. All right, right. This being exam or in a solving past papers or questions is become the chance of mistake reduces in this way, students. Okay. What a question. Next part. He's saying that 1.5 kilogram particle is held at rest at A. So it means the starting velocity here is 0. Read and write. 3 kilograms is in a limiting equilibrium. Okay, it limiting equilibrium means same thing. We can say here, limiting equilibrium means again, it is not moving. So velocity is also 0 here. Okay, and limiting equilibrium is just about to move, but not moving, just about to move. So 3, okay, and AB is X. This distance is very clear. Distance BC is 4, very clear. Show that coefficient friction between B, add here. Okay, and these are 0.75. So let's see how we can find it. Okay, this first part, I will concentrate only B particle. So B particle is this, and he said what? He said what? And what is the mass? 3 kilograms. So this is a 3 into 10, 30 newtons. And you know, weight acting downwards is what? 30 sine alpha. And backwards is friction because it is about to move, not moving, acceleration 0. He said limiting equilibrium means acceleration 0. Okay. And what is a basic technique? Net force is equals to MA. Start always from here. So net force means this friction, this force minus this. So 30 sine alpha minus friction equals to mass into A. And sorry, this is 0. I will not waste my time. And friction will go there. So I got F is equal to 30 sine alpha. F is mu R, 30 sine alpha. Now I'm going to plug in. What is R? Where is R? R is this. R is upwards. And this component is this way. So 30 cos alpha. Now, students, I'm going to plug in the numbers. This is a 30 cos alpha. Okay, this goes down and 30 cancel and cos over this alpha, sorry, not 30. And this is goes down, become 10 alpha. And 10 alpha is actually 3 by 4. So I think I should not work for this, but this will maybe help next part. Okay. And just extra knowledge even because cos will go down, sine by cos 10, 10 alpha is 3 by 4, 3 by 4 or 0.5, same thing. So proved. So Alhamdulillah Rabbil Alameen, let's go for next part. Next part is here, and there's I think second last part. After that, that's no, okay, let's finish. And 1.5 kilogram particle is released from rest. Released from rest. It means starting velocity was 0, and after it's moving, releasing means is moving. In a subsequent motion, the two particles collide and coalesce. Coalesce means they will become a one particle. And time taken for the combined particle to travel from B to C is 2 seconds. This diagram is very important for us, okay, and better to, or I can draw my own 1.5 because diagram is very, very important. Okay, this alpha, okay, this particle is here. And this particle is here. Okay, and gap between them is what? I think is a X meters. Let me check. Yeah, X. And the other one is till bottom is 4 meters, 3 and 1.5. There's a 1.5, there's 3, and from here till here is 4 meters. So students, I think now we can plan what is the question he's asking for. In a subsequent motion, they will collide, and the time taken for the combined particle to travel from B to C. From B to C. Let me think of A base, A, B, C, A on the top, B here, C at the bottom. So A, B, C. This is A, this is B, and this is C. So he said time taken for the combined particle to travel from B to C. So it means this time, this as from here to here, time taken, distance is 4 meters, and time is 2 seconds. Coefficient of the friction of the combined particle plane is that one. So coefficient. So what is the coefficient friction from here to there for the combined particle and the plane is still, it will not change that, because is the nature of surface. Okay. So student, now we have to find out X, right? So have a plan, we have to pick a plan, and then inshallah, I'm going to start. Let's see how we can do it. So planning students, what we have, you see here values are more, okay, in numerical form. Here values are less and second variable form. So how we can do it? If I think about distance 4 from B to C and time is 2 given, so I think it will help us. Formula we can use, we have a 2 formula, 2s is equal to v square minus u square. But problem, last velocity we don't know. So this formula is not so effective. Whereas s is equal to ut plus half at square. This is effective reason. Time we have 2, s we have 4. Acceleration we can find for this particle, combined particle while traveling here, and time we have even. So this data is important to use, but problem only one left. While using this data, what is v? So this v for this motion is actually u. The starting velocity of this motion is actually ending velocity of this motion. So I will find out what is v here for this motion. That will become starting velocity of this motion. So I think plan is okay. So let's try to find out the last velocity after coalesce. So I will take this plan before collision, after collision, after collision and before. So before collision and after collision. Before they are going to hit, okay? So just before, they did not hit actually. And after hitting, they will behave as a one particle, they will behave as a one particle. Okay. And before collision, students, you can drag slightly back even, so no problem. And it's down. Okay, this is a 1.5 mass, this is a 3, and here this 1.5 and 3. Okay. What is the basic formula, student? M1 U1 plus M2 U2 M1 V1 plus M2 V2. But this coalesce, as he said, velocity remains same. So velocity is same. VV, look, I erase VV, V1, V2. So VV common. So this formula will turn to be M1 plus M2 is V outside. Okay, student, this V is my target. If I get velocity from here, and that will help us to get U. So let's try to do it. In the beginning, it was traveling this way. Okay, starting, is it traveling down? So this is at rest, is equilibrium. He said limiting equilibrium. So velocity is this 0. And masses are, if you add them both, become 4.5. 4.5 V. This is our target is here. But problem is that when it's just about to hit this one, what is velocity at that moment? That is, this is 0 because it rests. So here, not a big issue. Issue is coming, what is velocity? So 1.5 into U1. This is interesting. When it was about to hit, Okay, so that is important to find it. And I will find it, say this is also important. So I will do it here. So get ready, students. What is the basic formula? V is equal to U plus AD. V is my target. Actually, this V is just, it is about to hit. U is starting from rest, as he said. U is 0. Acceleration and time. Wait a minute. Acceleration and time. Okay, acceleration. I think this equation will not help us. Reason time is not given, and time is not. Yes, before. Wait a minute. From B to C. That is 2 is for after this, not before. So it means this formula is not effective if I use the other formula that is more effective. And that is what? 2AS equals to V squared minus U squared. To acceleration, I don't know a distance. Wait a minute, distance. Okay, is X. Distance is X. Okay, acceleration is my target even. Last velocity is target, U is 0, as you know, is starting from rest. So a lot of variables we have. Now problem, we now are waiting for what is acceleration when it's traveling downwards. And that is, we don't know, we can find it. How to find that acceleration? If you look at this particle is downward moving, what is this weight component? You know, this weight component. And I think so first particle, no friction. Let me check again. Yeah, no friction. F is 0. So it means this, students, I'll go back. So it means when particle is backward is a friction, and that is 0. So what is this? Mg sine theta. And what is mg into 10 is 15. There's a 15 sine theta or sine alpha. And sine alpha, you see, I found before, better to this use again and again. So I will copy this and I bring it down. So I need it again and again. Okay, I just copy here. So sine alpha and cos alpha. And sine, okay, what is sine alpha value? Student, 3 upon 5. So it means 15 times to 3 upon 5. So I can say that net force is equals to MA. So 15 is sine alpha. Look, I write for you 15 sine alpha minus friction 0, mass is 1.5, acceleration. Sine alpha is 3 upon 5. When I plug in 15 into 3 upon 5 and 1.5 acceleration, this will divide and I'll get my acceleration. And acceleration is coming. Let me check in calculator. 5 to 15, 3 3s are 9. And 9 divided by 1.5 is giving us 6. So acceleration is 6. So I believe you got it. So this 6, student, I'm going to plug in it here. I got 12x v square. Take a root of the whole. I got 12x in a root. So this velocity, it's about to hit with that. This will behave as a u1. So root of 12x. And this 4.5 will divide. You know, student, 1.5 divided by 4.5, I got a 1 by 3. So velocity turned to be this, and this become 1 over 3. So root 12x must be inside by 3. This final velocity of this just before hitting will become starting velocity. So I believe you got a point. Now I can finish my question, students. So let's talk about, this is first A to B. Here he talk about A to B motion. And now I talk about B to C motion. Okay. All right, students, make sure now they are, what is the starting velocity? This is last one. So I'm writing U is equals to root 12x over 3. Okay, what is the time? As we know, 2 seconds. You see a lot of work, lot of attention required. Okay, and formula, I'm going to use this now. I believe you're understanding now. And S is 4, U is 12x by 3 root come to top. Time is 2, half time. Another trouble came now. What is acceleration of this particle after collision? This is another trouble now coming. So I will find this acceleration, this here, and t square. If I get the acceleration, I will get my answer of x. So it works, student. Now I have to work out for this acceleration, but it's not here. Combined particle, when after collision, we coalesce. So let's talk about that. So this is a combined particle that is a 4.5. How 4.5? Because 3 and 1.5 together. So this is a weight component that is a 45 sine alpha. And what is this? Friction force. Okay. And students, now I'm going to find out the other acceleration. Okay. So a lot of work still to be done, no problem. Patience, required patience. Okay, now net force equal to MA. Can I say 45 sine alpha? 45 sine alpha minus friction equals to MA, 4.5 times to acceleration. And 45 sine alpha is 3 upon 5. If I plug in 3 upon 5 here, let me check in calculator. So 45 into 3 over 5, 27. This is becoming 27. And what is F value, student? Mu R. Mu R. What is R? R is upward, and this is mg. So mu is what? 3/4. We found in the previous part. And what is R? As 45 sin alpha, this is 45 cos alpha. 45 cos alpha equal to 4.5 acceleration. And what is the cos alpha, students? Cos alpha value is this one on the top, 4 upon 5. And when I plug in 405 here, look, I type for you. Okay, so this is a 4 cancel out. 4 9s are 9, 3 are 27, 27 minus 7, 0. So acceleration coming 0. So acceleration coming 0. I think you got the point. Okay, and it means acceleration 0. I will plug in 0 here. So this is gone. Now 3 will multiply there and 2 will divide. 3 into 4 by 2 equal to root of 12x. This is becoming 6, squaring both sides. So 36 equal to 12x, and x becomes 3 meters. And I think you got a point. This was a really tough question, 6 marks. Okay, anyway, I believe you got a point very well. Okay, student, now let's go for the next part. He said the total loss of kinetic energy of the particle from the 1.5 is released from until the combined point reach C. It means we have to find, student, the whole story. Okay, best technique, I think we have to take this copy, or I make it again, no problem at all. This is diagram is also okay. And because we need it, okay. And this lot of work still is there. So that is why I'm doing it below. So students, let's see, this diagram is very important. Let me erase the things which are not required. Okay, this is okay. I think this is a time is not required. Distance is required only. Okay, now students, sine alpha, you know already 3 upon 4, and sorry, alpha, sine alpha is enough. Okay, now student, if I draw this triangle, so this is a total, as this x is 3 meters. Now I'm erasing this x, I'm writing here 3 meters. Basically, what is the plan of action? If we ask here, total loss of energy. He did not talk about kinetic energy. No, not potential energy. He asked both. So it means I will find both energy. So let's talk about here. What is kinetic energy here and what is potential energy here? Kinetic energy is 0 because starting from rest. So I will find out potential energy at A on the top. So mgh formula. Mass is 1.5, gravity 10, height is what? Uh-oh, this I don't know. So this is a triangle. I will make a big one. This is how much total? 7. Actually, I draw this triangle again for you. I believe, inshallah, understanding. This is alpha. This is 7 meters altogether as a height. So opposite by hypotenuse is turned to be h by 7 equal to sine alpha. And sine alpha 3/4, 7 multiplies there. It becomes, h becomes what? 7 multiplied 7, 3 at 2104. So this is a height 2104. So 15 times 2, 2104, I get what? Wait a minute, 2015 mg sine theta. Let me check again, 1.5 into 10 into height. What is the height, students? 7. Wait a minute, 7 times 2, 3 upon 4. So 1.5 and 3 plus 4, 7, correct? Let me check sine alpha is 3 by 4. Oh, sorry, 3 by 5, sorry, 3 by 5. 3 by 5. This is 3 by 5. That is why 3 over 5. 3 over 5. Okay, student, now check again. 3 over 5. Yes, we got it. Before awkward number came, now we got it. Okay, it means I found all energies here because potential energy kind of 0. So I got all energies at A. Now at B, I will find all energies. Okay, students, but because students, I considered that this potential energy in height. So, and potential energy of this is 0 naturally here. Okay, but B particle, don't consider both particles together here, because although they are coming together, but because I found the A particle's total potential energy, now consider B particle only. So what is the potential energy of B? And okay, and second number, we will find not only one thing, we will find out two things here. And yes, potential energy of B particle. And what is that, mgh? Mass 3, 10 into h. What is h? Interestingly, this is h, the 4 now, okay? Opposite by hypotenuse equal to sine alpha. So 4 multiplies there, so 4 into that. So 4 into 3, means 12, 1205. So let's find it. So 30 into 1205, we got a 72 joules. Okay, this is done. Okay. Now, students, I found both particle A and particle B. This as a kinetic is a 0. I got all the potential energy. This kinetic also 0. As potential energy is this. And at this moment, both particles have a potential energy 0, but both have a kinetic energy. So kinetic energy at a bottom, at a C, and I will find out half mv square, but mass, I will use both because they are coming together. So 3 plus 1.5, I get a 4.5. And V is what? I just got it. Wait a minute, let me find. Okay, that is a V we need to find. Wait a minute. Now what left behind, students? Speed left only, right? Speed. What speed it reaches at C. That speed, we don't have it, so we will find it. Okay. All right. Hold on. Okay. So now speed is what? Because if you don't have a speed just before hitting the ground, you cannot get the answer. So, data is available. U is, okay. Now important part. U is because I think I can work here. Because for this motion, student time is S is 4. Let me write S4. Time is 2 seconds. And starting velocity we have now U. What is U? U is actually we have this. But I will plug in X value 3. 3. Okay. So when I plug 3, 36. 36 root is 3, and I got 2. Let's see again. 1 minute, please. 1 minute, 1 minute, 1 minute. Yes, exactly. Yes. 3, 12, 3 is 36. 36 root is a 6. We got a 2. And we need to find last velocity. So 2, okay, S is equals to, or acceleration, we have a 0. Okay. And we got it already. Okay. So I think I can work with a velocity V is equal to And wait a minute, please. Velocity, we have it, I think, here. Combine. Yeah, we can find this way even. And we hold on. Um, okay. Okay. Student, as we have acceleration zero, acceleration zero we found here. This is acceleration zero from B to C. So it means acceleration not velocity is not changing. There's a hint, okay? So what is velocity here? It remains same throughout the distance. So it means this formula, we can use it for that. So 12 root x over this one. So I think this is okay. And copy, and I use here. So it means what is the velocity? There's no need to work. Even we work out, get the same answer. Okay, it means this, students. What is a velocity here, students? I'm writing here. Okay. I plug in 3 here. When I plug in 3 here, velocity become 12 into 3, 36. 36 velocity becomes 2. So half mv square. Half mv square, let me calculate. Yeah, this 2 to cancel the power to, I get a 9 joules. Now, students, what is our net finally we have to find out. Net energy, if you find it here, because if you have to add these two energies, okay, it means potential energy and kinetic energy is 9 here. And if we check it, because potential energy is losing, what is total energy? Total energy is what? So loss of potential energy plus, loss of potential energy, and we have a loss, and we can say that, and plus gain in kinetic energy. Okay, speed is increasing. This is becoming a 9, and if we check it, this is a 9. You see, we got it here. And if you add these two potential energies, so it is a loss naturally 72, and so loss means negative 72 plus 63. Let me check 63. Yeah. So 72 plus 63, it is coming negative negative 135 plus 9, I get a negative 130, 126, 126. And negative is a total. So negative means a loss. So loss of energy altogether. I will not write a minus sign. I write 126 joules. Okay, I hope so you got the idea, because when particle will come down and down and down, it is losing its potential energy. And as going down, speed x is increasing, is gaining kinetic energy. So that is why loss in potential energy, gain in kinetic energy. I will add them. I'll get my answer, and I hope so. The point is very clear, and the paper is completely over. So student, I suggest you, after attempting, you will get done some mistakes. So please attempt this paper once again, and redoing is the very best way of improvement. And best of luck for exam. Pray for me. Assalamu alaikum wa rahmatullahi.